Hello. Nowadays we can see some flying machine in the sky. No need to get scared, it's not UFO, it's just a drone. Usage of drones are increased these days, but its security is decreased. People tries to steal drone and sell it on markets. In order to ensure the safety of the drone, we introduce our project Dark 1. With the name we can say that when people tries to access the drone illegally, they won't notice its presence as it works in the dark. Within that time we can send an awareness information to the authorized person. Components used. Arduino, used to control all other components. OLED display, used to display a message when it detects an obstacle. Gyroscope module, used to check the orientation of the drone. Ultrasonic sensor, used to detect any obstacle from all sides of the drone. GSM SIM 800C module, used to send a message to an authorized person. Arduino is an open-source hardware and software company, project and user community that designs and manufactures single-board microcontrollers and microcontroller kits for building digital devices. Arduino board designs use a variety of microprocessors and controllers. The boards are equipped with sets of digital and analog input-output pins that may be interfaced to various expansion boards, shields, or breadboards, for prototyping, and other circuits. The boards feature serial communications interfaces, including USB on some models, which are also used for loading programs. The microcontrollers can be programmed using the C and C++ programming languages, using a standard API which is also known as the Arduino programming language, inspired by the processing language and used with a modified version of the processing IDE. A gyroscope is a device that uses Earth's gravity to help determine orientation. Gyrosensors are devices that sense angular velocity, which is the change in rotational angle per unit of time. Angular velocity is generally expressed in deg/s, degrees per second. There are three basic types of gyroscope: rotary, classical gyroscopes, vibrating structure gyroscope, and optical gyroscopes. Its design consists of a freely rotating disc, called a rotor, mounted onto a spinning axis in the center of a larger and more stable wheel. As the axis turns, the rotor remains stationary to indicate the central gravitational pull, and thus which way is down. The gyroscope maintains its level of effectiveness by being able to measure the rate of rotation around a particular axis. When gauging the rate of rotation around the roll axis of an aircraft, it identifies an actual value until the object stabilizes out. Using the key principles of angular momentum, the gyroscope helps indicate orientation. Gyroscopes are available that can measure rotational velocity in 1, 2, or 3 directions. 3-axis gyroscopes are often implemented with a 3-axis accelerometer to provide a full 6-degree of freedom (DOF) motion tracking system. A gyroscope would be used in an aircraft to help in indicating the rate of rotation around the aircraft roll axis. As an aircraft rolls, the gyroscope will measure non-zero values until the platform levels out, whereupon it would read a 0 value to indicate the direction of down. An ultrasonic sensor is an electronic device that measures the distance of a target object by emitting ultrasonic sound waves, and converts the reflected sound into an electrical signal. Ultrasonic waves travel faster than the speed of audible sound, that is the sound that humans can hear. Ultrasonic sensors have two main components: the transmitter, which emits the sound using piezoelectric crystals, and the receiver, which encounters the sound after it has traveled to and from the target. In order to calculate the distance between the sensor and the object, the sensor measures the time it takes between the emission of the sound by the transmitter to its contact with the receiver. Ultrasonic sensors are used primarily as proximity sensors. Ultrasonic sensors are also used in robotic obstacle detection systems, as well as manufacturing technology.
GSM SIM800C modem with antenna modules baud rate is configurable from 9600 to 115200 through at command. The GSM GPRS modem is having internal TCP/IP stack to enable you to connect with the internet via GPRS. Is suitable for SMS, voice as well as data transfer applications in the M2M interface. Onboard regulated power supply allows you to connect a wide range of unregulated power supply. Using this modem, you can make audio calls, SMS, read SMS, attend the incoming calls and internet, etc. through simple at commands. The modem is built with quad-band GSM/GPRS engine, SIM800C from Simcom, works on frequencies 850/900/1800/1900 MHz. The modem will work with 5-12V DC, which can be fed either through onboard 2-pin RMC connector or DC jack. The modem is powered by a high current low dropout linear voltage regulator so as to withstand high surge current requirement, may rise up to 2A.
In this project we attach ultrasonic sensors on all 6 sides, so that if any obstacle is detected it sends signal to Arduino immediately. If it's some bird or any other things it doesn't matter, but if the objects hits the drone harder and the drone might misfunction, then in that case the orientation of the drone is monitored. If the drone's orientation is irregular then our project send a message to the authorized person. The OLED displays a message that an obstacle is detected by any ultrasonic sensor. Mostly if a person tries to steal it, first they try to get access to the drone using or without using force, but this project won't be visible to the thief as if it doesn't exist in the drone. Drones are helping in human civilization more and more. As a helping hand, our project ensures the safety of the drone. If something is happening to the drone, the authorized person can get a knowledge about the drone. In future development, this project can be used not only in drone, but also products,